Okay, so is it visible now? Tell me.
Yes, sir.
Okay, so now today we will start our third part, right? Part third of magnetostatics, right? So till now, what we have studied about the magnet, how magnetic field lines, spreaded all around the magnet, and we also find the magnetic field. We know about the small m, we know about the capital M, and apart from this, we also know about the forces, that is magnetic forces. Okay, how what will be the magnetic force because of the magnetic field, and we have also tried to compare with the electric field or electrostatics or electric dipole, right? So we had tried to compare with the electrostatistics with magnetostatistics, right? Here earlier it was q, and now we have a small m, right? It is called q charge and it is called polar strength of the magnet, right? So whatever we have discussed till now, in that you have to keep in your mind about the magnetic field and forces and capital M, right? And one more thing, like we know in the electric field F is equal to Q into E, Q into E. So similarly here in magnetic force we have F is equal to M into B, right? M into B, that's we know from the earlier classes, right? So now question arises, let's suppose, just to think about this heading, magnet in the external uniform magnetic field. That means we have magnetic field, right? This magnetic field, because of, we have produced this magnetic field because of any other phenomena, right? And we put a magnet over here, right? Here you can see here is a magnet. So when a magnet will be put in external uniform magnetic field, field is uniform, yeah, field is uniform. So when a magnet will be put in the external uniform magnetic field, then what will happen? So as we know that if we have a field and we have a pole, right? So this pole will force, right? This pole will feel force. It is similar like electric field. Suppose it is electric field, right? If you put over charge q over here, so q charge, sorry, yeah, it is electric field E. So this q charge will feel force q into E, q into E, this will fill, right? So similarly here, if we put a magnet, so magnet means two pole, north pole and south pole. So that means it will act as a magnetic dipole, right? So it is a magnetic dipole. So magnetic dipole will feel force. So in this magnet, what we have a north pole here, suppose, and south pole here, right? South pole and north pole, two pole are here. So these two poles will feel force. So what will be that force? That is be mb, and that is mb here. So one will be in this direction, other will be in this direction. Why? Because of opposite sign, right? So now suppose it is a rod, right? Suppose it is a rod and one force is applying in this direction and other is applying in this direction, and these two forces are just opposite, right? These two forces are just opposite. Okay, so now what will be the resultant force? So resultant force will be zero. Why? Because one in this direction and other is in this direction. So total force will be zero. That is why repeated where resultant force is zero. So now question arises here, torque will come in the picture, right? Resultant force is zero. Just to keep in mind, not force is zero, right? Resultant force is zero, not force is zero, right? So now we will go for the torque, right? So if anything rotates, that means there is a torque in that, a torque will develop in that, right? You know about the torque. So torque is what? Torque is r cross f, r cross r cross f, r cross f or f cross r, what is this? Tell me. Yeah,
R
tell me.
cross F.
R cross
F.
F. Good. So here you can see. So like force, just a minute. Suppose force is in this direction, right? And R is in this direction, right? So we will go R cross F, right? So we will use right hand rule, right? That means R in the direction of, just keep our. Do you able to see my face on the screen?
Yes, sir.
Okay, मेरा हाथ दिख रहा है?
हाँ.
Yeah, so how will we calculate the value, sorry, torque? So it is right hand side, right? So just to keep in R direction and then F direction, right? So it is in R direction and then F. So suppose it is R, right? And it is F, okay? Vertically we have R and horizontally suppose we have F. So R cross F. So in this way, right? Towards me what we have, that is direction of torque. Okay. So similarly here you can see on the screen that this is so F is in this direction. Yeah, F is in this direction. Here if it is north pole, then at north pole force in this direction. And where is R, right? So it is rotating from the center. Okay, it is rotating from the center. So R is in this direction. Okay, R is in this direction. That is, look at here, F is in this direction and R is in this direction. Oh, let's be right. Yeah, right. So this is the thing. So it is F and it is R. So R cross F, it will be inward. If you think it is on the screen, so simply just to put in the direction of R, just to right hand and rotate towards the F, and your thumb will give the direction of torque, right? So here it is. And one thing is, in vector, cross vector, right? Our cross product will give us sine theta. So we can write RF sine theta. We can write RF sine theta. So that's a written thing is over here. Yeah, where it is. This is the problem in Google Meet. Yeah, here. That is MB sine theta. Are you getting my point? So that is here. So M is magnetic dipole moment and B is electric field, right? So I'm just comparing about the F and R, which you learned in the classical mechanics. But here B is in this direction, okay, and A magnetic vector. So here will be torque will be not here, it will be force. Here force is acting as a this one. What do you say? That is, if you think about the capital M, so what is the value of capital M? Capital M is simply a dipole. What is this? Dipole, right? So in comparison of, if you compare to the electrostatics, so M is similar to the electric dipole. So just to remember there, P is sine theta. P is sine theta, right? You will go to the chapter of electrostatics and just you will find from there, right? If we have a dipole P and in this direction we have a E, then what will be torque? So that will be P cross E. P cross E. That is here same thing, MB sine theta, right? So what we got till now? We don't know it. If we put a magnet or magnetic dipole in external magnetic field, that magnetic dipole will feel torque, and because of torque, that magnetic dipole will oscillate, right? That magnetic pole will you know uh, will oscillate, right? So what will happen? It will go for oscillation, right? That means in this way it will oscillate something like that. It will oscillate something like that, right? So when it is oscillating, right, and for oscillation theta should be very small. Theta should be very small, right? Theta should be very small. So when it will go oscillation, and because of the oscillation, right, it follows some particular period, right, or time period or angular frequency, right? So we say in this condition that is go for SHM, simple harmonic motion. We know from the class 11 chapter. So this dipole, magnetic dipole moment will going to oscillate something like this, and when it starts oscillating, right, when it starts oscillating, then there is, we will say it is SHM, right? And when it will SHM, then there will be a time period. That means after a period of time, it will repeat itself, its position, right? You know about the pendulum, right? Pendulum, it will come here and after a time will go there. Once come go, something like that. So here we have a time period, right? So we will also find that in the case of magnetic dipole moment, what will be the time period, right? So that we will check over here. So look at here on the screen, first point, right? Just to think about the first point. So what is it? Torque acts as it tries to make M cross B. So torque is M cross B. You have to remember this. Torque is same of what every point of the dipole its potential energy is. That means torque will be constant at each point on the dipole. So suppose it is a dipole, right? So here, 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 everywhere will same. What? Torque. Torque will be same at each point, right? And what will be the potential energy, right? What will be the potential energy, right? So same thing, I'm just requesting you just to go to the electrostat chapter. You will find there electric dipole in uniform electric field. There you will find that potential energy, and potential is nothing but this one. You can see on the screen, that is minus mb cos theta or minus m dot b, that is dot product, right? Dot product. And here that is cross product, right? Cross product. So here you can see if theta is 0, if theta is 0, that is minus mb. So a state will be equilibrium. Equilibrium state. What is the mean of equilibrium state? Theta is 0, you can see on the figure, right? Here theta is 0, that means this dipole become the parallel of B, right? Parallel. So in this condition it will be equilibrium, a stable equilibrium. A stable means like this. Suppose this is a U, a ball is here, right? Sorry, this is problem of this one, right? A ball is here, right? Here, so it is a stable. And if you write something like that and ball is here, right? So it is unstable, right? It can fall down this, okay. Oh man, not too pretty. So now this ball can be fall down in this way or in this way. So it is unstable equilibrium and it is a stable equilibrium, right? So similar case is here. If theta is 0, that means if theta 0 here in the screen, on the screen you can see this dipole. So dipole is at angle, at angle theta, but theta is 0, this dipole will be something like this. So that is called a stable equilibrium. If theta is pi means this one, magnetic pole in this direction and B is in that direction. So B is in this direction and M become in this direction. So in this base it will be 180 degree. So in the case of 180 degree, what will happen? It is unstable equilibrium, right? We have to keep this mind. And this, in these two figure, one is something like that. It is wrong here, right? In this condition it is wrong here. It should be capital M, right? And here you can see in both in the same direction, so B will be in this direction, right? So this is wrong, okay? So either will be in this way or just opposite of it, right? So it is mistake here, right? Okay, so for a small theta, if theta is a small, then go for SHM, right? It will go for SHM. So it is a condition of SHM that theta should be a small, So here torque is this one, we know from here, right? Torque is equal to minus mb sin theta. So here torque is I alpha, we know from the rotational mechanics, right? So torque is I alpha. torque is I alpha, and other is m, I think L into R, sorry, L cross R. Yeah, R cross L. You will check this. Yeah, R cross L, sorry. So there are two formula of moment of torque. That is R cross L, I think, and other is I alpha. I is moment of inertia, right? And once again, I request you go rotational chapter and try to understand moment of inertia, right? There is a good lecture on YouTube, and it may be in your classes where you are studying. There you will find the know lecture of moment of inertia, how to find moment of inertia, just to go through that and understand all the things. If you get any kind of problem there in moment of inertia, then you can message me. I will make you understand you all right. And just to look those all the things, if you get any problem in moment of inertia, then tell me. I will also manage a lecture for moment of inertia and rotation, these all, and center of mass, right? So anyway, so minus mb sine theta, right? So minus mb sine theta is same thing, and torque is equal to I alpha over here. And you will find that here that here it is minus. You will find that here it is not minus. Here is minus. So don't worry about that, right? You minus because of, if I take minus m, then it will be minus. No problem in that, right? Okay. So now look at here. If theta is very small, so we know from mathematics that sine theta can be written theta, right? So here same thing. Sine theta can be written theta, right? Sine theta equal theta. So alpha will be this much. So what will be alpha? Alpha will be this much. Okay. So what is alpha? Tell me. What is alpha? Yeah, anyone? What is alpha here? Hello. What is alpha here? Yeah, tell me what is alpha here? हेलो, सुनाई पड़ रहा है आप लोगों को?
Yes, sir.
हाँ, तो बता भाई अल्फा क्या है? अल्फा इज एंगुलर एक्सिलरेशन.
हाँ.
Alpha is angular acceleration. Suppose it is a rod and it is rotating in this way, right? So it is rotating or accelerating with angle, right? So that is alpha. So we know torque is equal to I alpha, and I is moment of, yeah, moment of inertia. Moment of inertia, right? That's I'm telling, just you have to study about that, how you can find the moment of inertia, right? So here what you have studied that, you had studied about the torque, that is mb sine theta. Mb sine theta is equal to I alpha, then alpha will be, I will go in this way, and from where I can erase this I. So this is our is, and this theta, this sine theta can be written as theta, right? So the overall result what becomes mb sine theta alpha, and minus is there, then I can write minus over here. And one more thing, if go for the SHM, right? If you go for the SHM, what you will find that if it is SSM, right? So there is a condition, right? For there you will find what, something like minus omega square theta, and something like you can see, you will find here. Yeah, this is uh, just a minute. Yeah, yeah, sorry. Yeah. So alpha is equal to minus omega square theta. This is relation of SHM. Do you know this thing? Yes, yeah, no.
Yes, sir.
Yeah, you know, good. You know this thing. So same thing is here, just you can see here what we got here. So what is this? So alpha is equal to, so one I write alpha equal to mb upon I minus and then theta here. Same thing. If he compares, then this will become omega square. And omega is what? Angular frequency. Omega is angular frequency. So what happens clearly? So what happened? So now we have omega equals under root mb upon I. Now what is the mean of that? That if we have a magnet in external magnetic field, magnet or magnetic dipole moment, right? And it's making angle theta, okay? So it will rotate, oscillate, not rotate, oscillate, right? It will oscillate. Condition theta should be very small, very small. It is the condition over here. So in this condition, we have an angular frequency, this one. Okay. So if this dipole has magnetic dipole moment capital M and external magnetic field is B, and moment of inertia of this dipole, and suppose this is a magnetic dipole moment, so this magnetic dipole moment can be created by, suppose there is a rod, it may be box, right? It may be something rod, something like that, right? It may be cylindrical shape, right? Any kind thing be here, right? So this moment of inertia is of this shape. What will be the shape? Accordingly we will put the moment of inertia. Suppose we have a rectangular shape, something like that, and this length is a and it is b, and it is rotating up from here or from here, right, in this axis. So what is the moment of inertia from here, right? So you have to know moment of inertia of this shape around this axis. And if I rotate from here, so moment of inertia will something different. Suppose we have a circular disc, so for this from center it will be something different, from here it will be something like different, right? And from, if you rotate by in this axis, something like different. Okay, so magnetic dipole moment will exist in any kind of shape, like circular, rod, or cubic, or rectangular, or circular disc, whatever. So as per the shape, you know about moment of inertia. So if you know moment of inertia of this object which is producing magnetic dipole moment, and it starts is oscillating or SHM, then we can calculate angular frequency. Angular frequency, what is frequency of this oscillation? What is frequency of this oscillation? Like suppose we have a beef. I want to describe some more things so that you make very clear. Suppose we have a pendulum and it is oscillating something like that, okay, and it's making angle theta, right? So in this condition also we calculate omega. So in, suppose we have a wave, right, sinusoidal wave. So what is the it's like we, this is a wave, so we can write that suppose a wave, I can write if omega equals to a sine omega t. Suppose it is something like, so this is omega, right? This omega is the same omega. That means this is sine wave. So this sine wave has frequency. So what is frequency? So this to this length is lambda. This to this length is lambda. And frequency is, what's the frequency? Tell me. Frequency is 1 upon t, time period, right? What says time period? And what is, so omega is equals to 2 pi upon 2 pi upon lambda,
T.
2 pi c by lambda. Yeah, 2 pi c by lambda, because 2 pi in one rotation we have something by 2 pi c by lambda. Once a minute. Now omega is equal to 2 pi nu, nu is equal to c upon lambda, right? You know from the modern physics. Yeah, anyway, I want to focus here this omega, right? So this omega, but that means this wave is oscillating with frequency omega, right? So same thing is there. If we have a dipole, so it will oscillate something like that. So because of oscillation there is a waveform, right? So if we have a waveform, then it's there will be, you know, there will be frequency or angular frequency. So that is same omega we have calculated there, right? So what we had not till now, we calculated omega, and once we know omega, then we can also find capital T, right? So what will be capital T, tell me? So omega, what we got, under root mb upon I. So what will be time period?
Hmm, time period.
Yeah, so time period is equal to 2 pi
Omega,
omega, right?
omega by 2 pi.
Ha, sorry, omega by 2 pi,
Yes.
2 pi by omega, sorry.
2 pi by omega. हाँ, 2 pi
It is,
by omega.
what is, so from here you calculate, you will put something like that and you will go to your result. Okay, so time period is equal to 2 pi under root, that means under root I upon
MB.
mb. So this is time period, that means it will oscillate after time period of this one, like something like pendulum. It will go here come. So it is t, right? It is t here, so one time period, right? So similarly it will also oscillating. It will go here and one come will here, right? It will go there and come here. It may be going this way, in this way, right? So it will oscillate something like that. Okay, so till now we have calculated this one. So there is a question, तो वो क्वेश्चन तुम लोग बनाए थे, ये बताओ, ट्राई किए थे? अभी तुम्हारे पास है वो क्वेश्चन, तभी तो तुम लोग ये देख रहे हो। मैं इसके पे खोलता हूँ एक क्वेश्चन में, सबको तुम लोग पढ़ो, देखो थोड़ा और बताओ कैसे बनेगा। ये पढ़िए थोड़ा। A bar magnet of mass 100 ग्राम लेंथ 7 सेंटीमीटर विथ 1 सेंटीमीटर, है ना? मतलब एक मैग्नेट है ऐसे, स्क्रीन पे देखो सब कुछ। अरे just to look at on the screen, magnet we have and 100 gram, that is mass, 7 centimeter length, 1 centimeter width, height that is 0.50 centimeter. Okay, and takes pi by 2 second to complete an oscillation. Pi by 2 seconds, to oscillate. Okay, horizontal magnetic place in the horizontal magnetic field of this, it is magnetic field value, that is b equals 25 micro Tesla. So Tesla is unit of this, so 25 into 10 to the power minus 6, 10 to the power minus 6, that is the value of b in terms of Tesla. So find the magnetic moment of the magnet. Magnetic moment, are you getting my point? So how will you find magnetic moment? Yeah, tell me. How will you find magnetic moment? So I want to show this.
That's it. T.
Yeah, listen, magnetic moment is equal to m into b, right? No, sorry, wrong.
M into L.
Yeah, m into l, right? Or a or 2, whatever. So in this condition we don't have m, right? Okay, but here we have, what we have, a b bar magnet. Bar magnet means something like that. Are you getting point? Bar magnet. Okay, bar magnet, 3 dimensional, right? So B have a length, B have a breadth, and B have a height. Okay, so we know that one thing, that time period equals to under 1 upon 2 pi under root I upon mb. We know this thing. Okay, so time period it is given, moment of inertia we can calculate from here, right? And mb we have to calculate, b we know that is already given, so we can calculate m from here, isn't it?
1 upon 2 pi here, 2 pi.
Yeah, whatever, whatever I have written formula, I'm just regarding that, we know I, we know b, we know t, so we can calculate him. Are you getting my point?
Yes, sir.
Yes, I know, don't bother, 2 pi will be here, don't worry. So I'm just telling how we can calculate. So we calculate it is simply you can use formula, but here you have to keep in your mind I you have to calculate. So you have to know about the m upon 12 under root length square plus breadth square, right? You have to know this thing. So it is simple. It is simple, moment of inertia. If you find the lecture of moment of inertia, how to find it, there you will find very easily what will be the moment of inertia of rectangular shapes, or cuboid shape, right? Both are same thing, right? If you go through this axis, then you have to find this breadth and this length. And if you go in this way, right, in this way, you have to take height. You have to consider height instead of width. So that is the thing. So moment of inertia you have to calculate, and then other thing can be calculated. So you will complete this one, will you? Okay, now look at the second question. इसका आंसर तक आप लोग पहुंचोगे. ओके, सेकंड क्वेश्चन देखिए. If the magnet is put in magnetometer with its this centimeter is horizontal, what would be the time period? Right, now question is length has changed now, right? Length has changed now, so what will be the time period? Okay, so one thing is, from this question we know, if the magnet is put in the magnetometer with its this centimeter is horizontal, what would be the time period? So now earlier time period was how much? It was pi by 2 second, right? But now time period is different. Okay, so what will be that time period? So we a length has already changed, and we know capital M we already calculated from first portion, so we will use that capital M, and we can find the second answer. Okay, so we will calculate these two. It is as simple as it is. I hope you will answer that. And कल मेरे को बताओगे, you will tell me tomorrow that if have you got answer or not. Okay, okay, move to the next question. Look at here. It is a very interesting question. Find the torque on m1 due to m2. It is m2, right, and it is m1. Okay, I will solve this on whiteboard, but look at the picture. Okay, m2, due to m2, sorry, find the torque on m1 due to m2. We have to calculate torque on m1. That means in this one we have to calculate torque due to m2, due to m2. Okay, this thing is clear. Now come to on whiteboard so that you can understand better. So what is this? We have a such kind of magnet, right? Okay, north is here, north is here, south is here, and south is here, north here. You have to understand very carefully about these things. And this is r is from center, right? Center to center distance, center of this magnet. Okay, this is r, so this will be how much? This will be r minus a. I want to draw the electric field lines, something like that. Let me take different color. Where is those? Where is color option, man? Yeah, here it is. Yeah, magnetic field coming in this way, north to south, or from here also I am just writing north to south. सही है? Is it fine? Sorry, it will go in this way. Here it is not. Is it fine? North to south? Yes या no?
Yes, sir.
Yes. हाँ तो बोला करो भाई. You have to say yes so that I can go ahead. And then it is a magnet. It is a magnet. Okay. So magnet means I'm just writing a line, and that means a magnetic dipole moment. So this is a magnetic dipole moment. This magnetic dipole will create magnetic field. So we have a magnetic field. So now this magnetic field line, that is red one, or this line will apply force on this pole, or we can say this pole will feel force, right? Will feel force because of this magnetic field, right? So south we have a minus m, right? And for north we have a plus m. Is all right? So this minus m will feel force in which direction? Tell me. Upward or downward? Direction of magnetic field is here in this direction. Are you getting? So force will be in which direction? Tell me. Yeah, don't take too much time. हेलो.
डाउनवर्ड होगा.
डाउनवर्ड होगा? क्यों भाई?
यस.
भूल गए सारे? देखो यहाँ पे पोल है एस, राइट, एंड मैग्नेटिक फील्ड इन दिस डायरेक्शन, बी इन दिस डायरेक्शन. तो टेंजेंशियल विल बी समथिंग लाइक दैट, एंड हेयर it is minus m. So if it is minus m, so what is force? So force is equal to m into b. M into b. So m is positive, then direction of b and direction of f will be same. But when m is negative, then what will be the direction of b? Just opposite of f. Are you getting my point?
यस.
Yes. So what will be direction of force here? Upward f. Got it? And
Yes.
here will be downward. Why? Because m is positive. So when m will be positive, if it will be positive, then what will the direction of f and b will same. क्लियर? यहाँ पे बोलो, ये बहुत जरूरी है समझना डायरेक्शन. So
यस, क्लियर.
yeah, so upward it is called f1, and downward it's called f2, right? So that is the thing. Okay, right. So what we have to calculate? We have to calculate torque, right? So how we will find torque? So torque is what? R cross F. Torque is R cross F. Torque is R cross F, or we can say RF sine theta. So we have to calculate torque on M1 according to question. Torque on M1 due to M2. So M1 is this one. M1 is this one, right? It means this magnet will rotate, right? This magnet is going to rotate, and when this magnet will rotate, that means production of torque, or production there will be a torque over here. So torque will be this. So it will rotate from this axis, right? And force is applying here and here. Just I want to draw other figure, so clarity. So here it is a magnet, right? And it is south pole and it is north pole. If suppose a force F1 is applying in this direction and F2 is in this direction, right? And it will rotate along the axis, right? So this direction is A, sorry, distance is A, and this is also A. So what will be torque? So actually we know torque is equal to R cross F, right? And it will be RF sine theta. And what is theta? So theta is angle between the R and F. right? So here this is the axis of rotation, and from there force is here, right? So r is in this direction, and it is axis of rotation. From here f2 is here, so it is in this direction. You have to take in this way. So here it is 90 degree, and here also 90 degree. That means sin theta is going to 1. So if force will be, if force will be in this direction, then theta will not be 90 degree. So we can't say sin theta is equal to 1. It will be something different. Suppose it is 60 degree. In that condition we have to use different value, right? So torque will be how much? F1 into a is distance, this one, f into a, plus this one, right, f2 into a. Now the question arises that कि both will be plus or one, it may be f1a and second one is f2a. So why I have written same thing, that is both are in plus sign. Why? So you can see over here, for direction what we do, r cross f. Just look at here, it is r and it is f, right? So go r cross f. So r cross in this way, you can see this is clockwise, this is clockwise, right? So here look at, it is r and it is f. So r cross f, it is going anti-clockwise. Here it is r and it is f, so r to f, it is also anti-clockwise. So both are anti-clockwise, that is why I am writing both are in plus, right? Otherwise if one will be in clockwise and other will be anti-clockwise, so we have to write just opposite sign. So total torque is this one. Because theta is 90 degree here, that is why I have not taken sin theta value over here. Sin theta become to 1, right? So that is the same. So now total torque is equal to this. So now tell me what will be F1 and what will be F2. So we know force is equal to m into last time we have calculated mu naught upon 4 pi or m upon rq. Tell me, so what will be F1? You have to tell from here. Yeah, this F1 and this F2, right? From earlier classes we had discussed over that. Yeah, in this solution it is wrong here, it will be q. Okay, it is missing here. So this formula we know from last classes, we know this is the formula of f, right? And here we have written r minus a. Why? Because this one is r minus a in the last slide. Where it was, yeah, this one, this one. So f1 is here, so at place of f1 we will write r minus a, and for this it will be r and this is plus, so a, so it total length will be r plus a, right? So that's written over here. Here you can see r minus a and r plus a. Okay, and what will be the magnetic dipole moment? Which magnetic moment will we have to consider, m1 or m2? So we have to consider m2. Why? Because of m2 we are calculating torque, right? m2 hai, because of m2 we have a magnetic force, and because of that magnetic force we have a torque. So we don't have to write m1, we have to write m2, right? So from here we will calculate this. So there one condition has applied, that a is much lesser than r. So here a has deleted here, a, just to make a is equal to 0 here, a is equal to 0 here, then this result you will find, and from there you are this one. So this is your final result. Till now tell me if you are getting any problem in this to understand this all, tell me. I will try to discuss this. यहाँ तक क्लियर है तो बताइए यस, अदरवाइज कोई प्रॉब्लम है तो बताइए. टेल मी गाइस.
सर वहाँ पे दोनों ऐड हो गया ना, वहाँ पे नहीं समझ में आता.
ओके, दोनों जो ऐड हो गया, यू आर नॉट गेटिंग दैट वन. ओके, नो प्रॉब्लम. लुक एट हियर, लुक एट हियर. आपको किसी ने 5 रुपया दिया, ठीक है? सपोज ए पर्सन हैज गिवन यू 5 रुपीज and B has also given 5 rupees. So how much you have? You have to add. You have to add, and then you will get 10. So similarly here, this magnet is feeling force F1 here and F2 in this direction. Suppose F2 is not here, right? And if we are applying F1 here and it starts rotating, right? So it will feel torque tau1, that will be, suppose it is A, right? So A F1, or we can say F1A, if F2 is not there, right? Now suppose F1 is not there, only F2 is there, so we will find torque 2 is equal to F2 into A, because this distance is also A. It is rotating from this axis, so we will take distance from here. Now this is our axis, so from axis what will be the direction of R? So direction of R is from axis to F, so it is axis and F is in this, so R will be in this way, right? Suppose F will be here, suppose we have this origin and this is a point, right? And F is applying here in this direction, right? So R is this, so R will be in this direction, right? So this is R and this is F, but in this case this is direction of R and this is direction of F. So R cross F, so R cross F like this. Similarly, if you consider F2, so what is the direction of R cross F? So R cross S is anti-clockwise. Okay, now here R in this direction, F is in this direction, so R cross F, so it is also anti-clockwise, so it is anti-clockwise, right? So direction for tau2 and tau1 both will be same. So one tau1 because of F1, one tau because of F2. So what will be the total torque? So total torque will be tau1 plus tau2. So that's I have added this over here. Understood or not?
Yes, sir.
Yes.
Yeah, Mantu, Suraj, tell me.
Yes, sir. आ गया.
Okay, earlier was problem in this. Yeah, भाई मुस्कान नहीं पूछी थी उससे पहले प्रॉब्लम में थे. Okay, and here
Yes.
one thing is more, a technique here. Here it was M2, but now here M1 come in picture. So how M1 comes into picture, you know, right? In last class we have already discussed this concept. So I request you
Yes.
all guys just to solve these all questions to your own self, right? So our next topic is magnetism due to electricity, right? So which we will cover in next part, right? It's all right.
Yes, sir.
Okay, so I will
Yes.
stop sharing and also I will stop recording.